Introducing VIST5, an adaptive, retrieval-augmented language model designed for visualization-oriented dialogue. The system facilitates natural language communication through a chat or voice input located on the left side of the interface. On the right, we find a geographic map for geo-related plots, as well as a display for Vega light visualizations below. One of the main limitations of existing systems is their inability to quickly adapt to the specifics of an application domain, such as climate data exploration. Developing a dialogue agent for these domain-specific interactions is challenging because there is often little or no linguistic data available. In addition, the use of large language models such as GPT-3 is not feasible for certain domains, either due to privacy concerns or computational constraints. VIST5 provides 3 solutions to these challenges. First, it uses an efficient online annotation tool that allows easy adaptation of the dialogue system to the linguistic peculiarities of a given domain. Within a conversation, users can correct system responses and resubmit them to the training set, allowing the language model to be retrained quickly and efficiently. Second, VIST5 facilitates the integration of new, domain-specific commands and interactions based on just a few examples. To integrate custom functionality, users only need to show how they want the tools or commands to be executed by the system. The dialogue agent decides how to behave based on these examples and can therefore be easily adapted to new domains without the need for training. This way, not a single line of code is necessary for the integration of custom functions. Third, VIST5 focuses on small model size, fast trainability, and fast inference on commodity hardware. This makes it usable by anyone on a CPU in real time, as opposed to large language models that must run on GPU clusters. Let us now examine a few key features of our system in practical use. VIST5 allows for the creation of Vega light-based visualizations via either voice or text input. Once a visualization is created, the system seamlessly responds to contextual queries. The response contains a freshly generated Vega light spec. This increases the level of trust between the user and the system by allowing the user to review and adjust the output results. In the conversation shown, a user explores the similarities and differences between 2 weather stations, one in Berlin and one in Copenhagen. First, the user compares the temperatures in both cities using line and scatter plots. The user then creates an overview of the range of temperature values in the dataset. After evaluating the overview of all cities, the user filters the range by the cities of Berlin and Copenhagen. Inspired by the observations, the user now wants to find out whether the temperature at the stations correlates with precipitation. Again, the user filters this general view according to the locations of interest, Berlin and Copenhagen. Finally, the visualization can be customized to the user's needs, for example, by adding an appropriate title to a chart. Vega light visualizations provide an effective way to explore data through common charts such as bar charts, line charts, or scatter plots. However, when exploring climate data, it is essential to view the data in the context of the geospecific conditions of the stations from which they were collected.
Create a marker for every city in the dataset. Reset the map. Show me a flow map of wind directions. Navigate to Copenhagen. Show me the average wind speed per month in Copenhagen. Zoom out. Zoom out. Navigate to Stockholm. Show me the average wind speed per month in Stockholm. Zoom in. Zoom in. Reset the map.
This concludes our brief introduction to the VIST5 dialogue system. Thank you for your time and attention.